Whoa! Hi, gang, how are you? I'm Howard. Listen, I got a question for you. How do you cross a river? You creak past him. That was a lame joke, wasn't it? And it was a lame answer, too, because everyone knows that you cross a river on a bridge.
Bridges come in all kinds of shapes and sizes. Some are long, some are high, some look rickety, some are sturdy, some bridges hang by wires, and some rest on blocks.
Bridges make it possible for us to get from one place to another without getting our feet wet. No matter how big or small, high or long, bridges have only three basic designs. A span bridge like a regular highway bridge, a suspension bridge like the Golden Gate, and an arch bridge like this one. What exactly makes them different? What does it mean, span, arch, and suspension? Let's take a look. Yuck. Straight. Straight. Roll over. I tell you. Hi. This is it's a fallen log. I know, big deal. But did you know that a fallen log is actually a terrific example of a span bridge? Yep. See, a span bridge is simply something that lays across two objects. In this case, it's a fallen log laying across two rocks, spanning the water. Let's go look at some other span bridges.
This is the Post Bridge. It lays across the River Dart in Dartmoor, England. The Post Bridge is one of the oldest span bridges known, completed sometime between 1000 BC and AD 1. That's thousands of years ago. As you can see, the Post Bridge is a lot like a log, except this bridge is made out of stone. Who built it? Nobody knows. This is the Kenzua Creek Bridge in Bradford, Pennsylvania. This is a span bridge too, except this one has lots of spans put together. It's over 300 feet high and more than 2,000 feet long. It was built in the 1800s for the railroad.
This is an average, ordinary freeway bridge. Like most freeway bridges, this is a span bridge. Later on, we'll look at some special freeway bridges. But first, do you remember what the other bridges are called? Right, an arch bridge and a suspension bridge. Junior Bridge Twister. Woo! Oh, hi. I just love these things. Listen, I thought I could use a hula hoop to show you the differences between an arch bridge and a suspension bridge. How? Watch. An arch bridge is shaped like a rainbow, and the deck, or roadway, can be at the top, in the middle, or at the bottom. Whichever way it is, the weight of the deck is always supported at the bottom of the legs, where my hands are. Oh, that's heavy. A suspension bridge is shaped like a smile face, and the deck or roadway always hangs from cables. Hey, watch out for the pool. Can you guess what kind of bridge this is? It's a suspension bridge. This is the Hennepin Avenue Bridge in Minneapolis. It crosses the Mississippi River. This is a beautiful suspension bridge. Can you see the suspension cables? Hey, let's look at the most famous suspension bridge, the Golden Gate in San Francisco, California.
In 1929, workers began to construct the Golden Gate Bridge in San Francisco, California. It was opened for traffic in May of 1937. That was 8 years later. The main span is 4,200 feet long. The Golden Gate Bridge was the longest suspension bridge in the world up until 1965, when the Verrazano Narrows Bridge was built in New York City. This is the Verrazano Narrows Bridge in New York City. As you can see, it's almost identical to the Golden Gate, except it's 60 feet longer. Every day, engineers are finding ways to build bridges stronger, higher, longer, and safer than before. Now let's look at some arch bridges.
G'day, mate. This is the Gladsville Bridge in Sydney, Australia.
The Gladsville Bridge is a concrete arch bridge. It's 1,000 feet long.
This is the Sydney Harbour Bridge.
The Sydney Harbour Bridge was completed in 1932. This is a steel arch bridge, and it has a really wide roadway and is 1,650 feet long. But the longest bridge in the world is the Lake Pontchartrain Causeway near New Orleans. This is a combination bridge that's mostly made up of small spans put together. End to end, it's almost 30 miles long. That means it takes about a half an hour just to drive across it. Now that we know what the different kinds of bridges are, a span bridge, like the Kinzua Railroad Bridge in Burlington, Pennsylvania, a suspension bridge, like the Golden Gate in San Francisco, California, and an arch bridge, like the Gladsville in Sydney, Australia. Let's look and see how a bridge is made.
Hey, Howard, we need this big hole dug. Why don't you help us dig it?
Great. Okay, I'd be happy to.
The Department of Transportation here in Phoenix, Arizona is building this bridge in the Salt River. Did I say in? Yeah, because of certain property restrictions on both sides of the river, they have to build into the river, along inside it for a mile, and then out again to connect with the freeway on the other side. That's what makes this bridge special. Usually bridges just go straight across.
This is Dick Weston. He's the resident engineer at the Arizona Department of Transportation. Dick is going to explain to us how this bridge is built. How far into this hole are they? This just started?
Yeah, he's down about 25 feet right now. And he's just going to keep screwing a little bit and then taking the earth out of the hole, spinning it, and then putting the auger back down in the hole. And he'll do that till he's 100 feet deep, and it'll take all day. And he just takes it over here and spins it off. Watch.
Look at that.
And that's how we dig the hole.
And these are called augers, not drills?
Yeah, these are called augers. They're like a screw, just like a screw that you would screw into wood. Instead of screwing into wood, we screw into the earth.
is this thing?
Well, this is what's called the steel casing. It's made of steel, and it's about 15 feet in diameter, as you can see. And we place this on top, or we place this inside the hole near the surface, or the top of the hole. And the reason we do that is to protect the workers, because when we drill, the soil loosens up around the top of the hole. And this prevents the soil from collapsing into the hole.
What is this thing?
Well, Howard, this is the steel cage. It goes down into the hole of the drill shaft. And
Oh, I see, it's on its side.
That's right. It's on its side, and it acts like the roots in a tree.
And so right now what these guys are doing is they're putting it all together before the crane picks it up and slides it into the big hole.
That's right, Howard. And once we have that lowered into the shaft, we'll pour concrete around it.
Let's go over and take a look. How far down is this?
This shaft's about 100 feet deep.
Wow.
And this will go all the way down to the bottom of the shaft. Well, Howard, you just saw one of our drilled shafts being poured, the foundation for the bridge, and this is the completed drilled shaft. You can see the steel sticking up out of the shaft.
And those will hold the columns, right?
Yeah, those will hold the columns, and the columns are over here. Now the next step, Howard, is the column. And the column, of course, sits on top of the drill shaft foundation. So we're going to set another steel cage on top of the drilled shaft. Now the next step is to pour concrete around the steel cage.
How do they do that?
They set this steel form and they fill it full of concrete.
This one's all dry. Hi, Rick, how are you doing? I'm Howard. You mean we're gonna go up?
Yes, we're going up.
We're going up. All clear up there, we're coming up! Well, this is like a magic carpet. What goes across these two columns here?
Well, Howard, we call that a column cap beam. Just like a cap you have on your head, it's a cap for these two columns and links them together, or joins them together. And this is what sits between each girder.
And this is how they make it? Right in here?
Yeah, they make it right in here. This is all the steel that goes inside the column cap beam, and this is all the forms that hold the concrete in. And they make it down here on the ground, and then they lift it up with the cranes and set it in place.
So this is all gonna get filled with concrete?
That's right.
Wow, that's a lot of concrete. Whew. Where are we now, Dick?
Well, we're on top of the bridge. These are the girders, the long things that run between the rows of columns. They sit on top of the column cap beams. And on top of the girder sits our bridge deck, where the cars drive.
Ah,
And so, if you look at these wooden forms, these go between the girders, and we'll pour with concrete this deck. This is it, Howard. Once we get the wooden form placed and we get all the steel put in, we pour this concrete on top of everything.
What's all this white paint on here?
This is called a curing compound, and it keeps the concrete moist while it hardens.
Okay, so this is the actual surface then that the cars are going to drive on?
Yeah.
And then they'll paint the stripes right on here?
That's right, Howard. And we have machines over there that finish the surface that give the deck a nice smooth ride.
Well, now that the bridge is all done, this is what you get. Dick, can you tell us again what the parts of a span bridge are?
Yes, let's start with the foundation. That's what's below the ground. And that's what the bridge sits on. And then what sits on top of that drilled shaft or that foundation is what we call a column. And the column is like the trunk of a tree, and the foundation is like the roots of a tree. And then on top of that column, we have what's called a column capsule. That sits in between each column, on top of the column. That's why we call it a cap. And then between each row of columns, we have the girder.
And those run the long way, right?
That's right, they run the long way. And then the last thing we have is the deck. And that sits on top of the girders, and that's where the car drives. And that's our bridge.
Sure can get cold up here in Duluth, Minnesota. Behind me is the Blatnick Bridge. At almost 8,000 feet long, it's the second longest bridge in Minnesota. It's located here in Duluth at the tip of Lake Superior. One of the things that makes the Blatnick Bridge special is that it's actually both a span bridge and an arch bridge combined. The Blatnick Bridge connects Superior, Wisconsin with Duluth, Minnesota, continuing the 535 freeway. Because Duluth is a harbor city, big barges and other ships come here to load up. Most of the bridge spans across on tall columns, but in the middle, over the water, there's a big arch section that's high enough so that the ships can pass underneath. So high, in fact, that when it was first built, the people around here called it the High Bridge. I'd just say, High Bridge! Anyway, now it's named after the late Congressman John Blatnick. Right now, the bridge is undergoing a huge renovation program. In other words, they're fixing it up. How huge is the renovation? Well, right now, this is the biggest bridge renovation going on in the country. This is Don Stanley. He's a project supervisor here with the Department of Transportation in Minnesota. Don's going to show us the Blatnick Bridge up close. Hi, Don.
Hi, Howard. Hi, Bridge. Howard, this bridge was originally opened to traffic in December of 1961. That's just over 32 years ago.
How long is the bridge?
7,975 feet, abutment to abutment.
Now that includes both the span part on the Wisconsin side, the arch part, and the span part on the other side, right?
Yes, it does.
Wow. Now, this is the most extensive renovation going on in the country right now, right?
I believe so.
Why is it being renovated?
The original deck had deteriorated badly, and we're replacing the deck with new technology, and we're widening it, adding an 8-foot shoulder to each direction so that the vehicles will have a place to pull off.
As you can see, this is where the old deck stops, and the new renovation starts.
That's right, Howard. This bridge has a lot of the same parts as the Phoenix Bridge. We have 2 main girders, with floor beams every 30 feet to support the stringers. We have a new girder on the outside that allows us to put a deck over the entire area and have an 8-foot safety shoulder on the outside.
How high up are we right now?
At this point, 115 feet off the ground. When the deck reconstruction is complete, Howard, the driving surface will be 461,244 square feet.
460.
That's more than 50 football fields.
We're out in the center part of the arch right now, Howard, where the deck is suspended on steel cables. We've got iron workers replacing any deteriorated structural steel that we're finding in the truss.
How much steel is going to be used in the renovation of the Blatnick Bridge?
When we're done, we'll have 26,721,272 pounds of structural steel.
Wow. Oh, thanks. Whoa. That's about enough steel to make 15,700 medium-sized automobiles. And hey, speaking of reinforcing steel, all of the reinforcing steel used in the reconstruction of the Blatnick Bridge, they call this rebar, by the way, is made from recycled automobiles. When the bridge is finished, how much concrete will you use?
Adding in the new deck, there will be 53,728 cubic yards of concrete in this bridge.
Let me think now. That's enough concrete to build a sidewalk 5 feet wide, 166 miles long. Whoa! Hey, Don, there's another bridge here in Duluth that has another way of letting the ships pass underneath. Can we go look at it?
Sure, Howard, come on, let's
Great.
go.
Come on.
This is the aerial lift bridge at the entrance of the Duluth Harbor in Minnesota. Originally, when it was built, it had a small gondola-like platform that moved back and forth across the channel. But in 1929, they changed the bridge, and to let ships come in and out, the whole roadway goes up and down. This is a type of movable span bridge.
We're in the pilot house in the aerial lift bridge in Duluth. And when the ships come into the Duluth Canal, the pilot house operator works on this board. This is how it works. You turn the key here, like that, and that starts the bell. Once the bell's going, then you can raise or lower the gates. This is the Duluth Canal. Right now, it's all frozen because we're in the middle of winter. But during the summer, the lift bridge has to raise up and down to let the ships pass underneath. The lift bridge goes up for all kinds of ships. Big ships like barges, sailboats, all kinds, sometimes up to 50 times a day.
Another type of movable span bridge is called a drawbridge. Probably the most famous drawbridge is the Tower Bridge in London. It crosses the River Thames.
Cry me river, I cried a river. Okay, open your mouths, fish. Here it comes. Wow, we sure saw a lot of interesting bridges. It was great to see how the bridges are constructed and maintained. Do you remember the different kinds? Yeah, a suspension bridge, like the Golden Gate, an arch bridge, like a rainbow, and a span bridge, like highway bridges, and this log. Oh, I got. Thanks for coming along. If you'd like more information on bridges, your local Department of Transportation would be happy to help you. And remember, you can always check your local library, like me. Hey, get back in there. Thanks for coming. We'll see you next time. All right, that's it. I'm after you. Hey,
you'd like to write to me, Howard, or if you have comments or would like to see more videos like the one you just saw, write to this address. Whoa! Come back here! That got away. I'll catch another address. See ya.